Welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on soil water potential that comes under the unit soil water plant atmosphere relationship that comes under the subject irrigation and drainage engineering for the students of third year 6th semester. Let us recall what we have seen in the previous classes. We have seen about what are the soil structure forms that are involved, what is the classification, what are the tension, and what are soil water potential. We have to be very sure from the previous lecture series that soil water tension and soil water potential are interrelated because they are helpful in holding up the capacity of the water with the help of both. Today's topic for discussion is soil water potential, so their components, how we are going to measure them, and what is the significance involved in it. Let us explore here what is soil water potential. As we all know that it is otherwise known as soil water tension, metric suction, or moisture tension, which is a measure of energy state of water in the soil. So here, as I have shown in this image, it represents the tensiometer, which possesses ceramic cup. And this is available in order to for us to identify what is the soil water or moisture that is available in order to uh, rectify whether it is useful for us to use them under soil particles for the help of crop growth. Here it is subjected to several force fields including the soil matrix, dissolved solutes, gravity, and external pressure. The total soil water potential is always said to be as the concept that comes under the energy state and metric potential. When the measurement of energy is required to move the water from a reference state to the soil matrix, then it is said to be as soil water potential. Usually, this metric potential helps in water absorption and surface tension, which is of 0 or negative. That comes under the soil water potential. The components of a soil water potential are metric potential, osmotic potential, gravitational potential, and pressure potential. Metric potential is the result of absorption of water to soil mineral surfaces and the surface tension within the soil pores. It will be helpful for us to pull the water and reduce its potential energy relative to free water. Metric potential is always 0 or negative. It is a primary component in unsaturated soils. Osmotic potential is resulted from the presence of dissolved dissolves and other solutes. Solutes lower the potential energy of water, meaning osmotic potential is always negative or 0, while it primarily affects plant water uptake rather than mass liquid flow. It is a critical consideration in the saline soils. Gravitational potential is determined by the elevation of water relative to an arbitrary reference level, and it is located above the reference point has a positive potential, which water below has a negative potential. The last one is pressure potential, which is negligible without the external forces. Without bonding, the external pressure is atmospheric and the pressure potential is 0. Here, you guys have to understand how the soil water potential is very relevant. It is commonly expressed in terms of units of pressure such as kilopascals, bars, or atmosphere. Another in centimeter, for example, a PF of 3 is negatively equivalent to 1 atmosphere. Common moisture levels are characterized by the specific problems, that is specific potentials, that is saturation capacity. The tension is almost 0. Field capacity, generally it is assumed to be as zero point 0.1 bar for sandy soils and 0.33 bars for fine textured soils. Pressure wilting point, where the plants can no longer extract moisture, typically at 15 bars of tension. The significance in irrigation is comes under the soil water potential and plant water uptake. The water potential is the driving force behind water movement in the soil. Water always moves from a region of higher potential to one of the lower potential to reach the equilibrium. For plants to grow, they must exert through energy to overcome the soil water potential to pull moisture into their roots. Instruments like tensiometers are used to measure the metric potential in the field. They consist of water filled tubes with ceramic cups that come into the equilibrium with the soil tension. Here are the engineering significance that are used with the help of these kinds of potentials that are it is used under scheduling irrigation, avoiding over irrigation, managing saline soils, designing efficient drips. So today's summary will be on what we have seen is total potential components like metric potential, osmotic potential, gravitational potential and pressure potential. Today's assessment question is in a non-saline unsaturated topsoil exposed to the atmosphere, which component of the total soil water potential is typical, the most dominant and negative? Options are metric, pressure, gravimetric and osmotic. And our answer is metric potential. These are the references that we have referred for today's class. If you guys have any doubt or anything, you guys can ping on these reference list or ping me anytime. See you at the next class. Thank you.